simply identifying some basic parts of graphs. Now here we have what's called a linear graph. Anytime you have a linear graph, it's going to look like a straight line. Now some parts that we need to identify, the intercepts. First off, the X-intercept. The X-intercept is where a graph crosses the X-axis. That's this horizontal line right here. So this graph crosses the X-axis at this number right here. You can see right here's a 2, right here's a 4, so right in the middle, my X-intercept would be 3. Now, one thing that you do need to know about an X-intercept, the Y value at an X-intercept will always be 0. And here shortly, in order to find an X-intercept, we're going to simply plug in 0 for Y. Now, the next step, our Y-intercept, is where the line crosses the Y-axis, and we see it's right here at -6. And right the opposite, in order to find a Y-intercept, my X value will always be 0, and that's always the case. Remember, X-intercept, plug in 0 for Y, Y-intercept, plug in 0 for X, and we'll remind you of that constantly. Now our slope is how slanted a line is, and by the way, the abbreviation for slope is actually M. And to see how slanted this line is, we simply have to count. We're going to count from, you can find any two what's called lattice points. A lattice point is where the graph crosses exactly. You see there where these two lines cross, it crosses there. We can use this lattice point. We can use this lattice point. This point right here is actually a lattice point. And in this case, it's hard to see, but you could use our X-intercept here as a lattice point as well. But all we're doing is counting from one lattice point to the next lattice point. We're going to count how far up it goes and how far over it goes. If the line slants uphill, what I like to do is go ahead and put a positive because this is going to be a positive number. In the next example, if a line slants downhill, it'll be a negative number. If the line is horizontal, the slope will be 0. If a line is vertical, the slope will be undefined, and we can show you that later why that's true. But again, slope is equal to rise over run, and all that is you're counting boxes. You're counting how many boxes you go up. Now, this is hard to see, but you actually have 6, 5, 4, 3, 2, if you're going to count all of them. So that's going to be 1, 2, 3. My rise is 4. My run, we're going to go from here's 0 over to 1 over to 2. So my run is 2. And again, it's harder to see on that on this one because my boxes, the way it counts. But my slope in this case is actually a positive 2. That's my slant. The next one, let's do it again. My Y-intercept is where the line crosses my Y-axis. So that's going to be a value of 0 for the X and 4 for the Y. My X-intercept, now this one crosses at an odd place. Notice that my X-intercept doesn't always have to be a nice clean value. Here you see that each box here counts, let's see, there's 5 of them, so that'd be 5.2, 5.4, 5.6, 5.8, and then 6. So this is going to be, I'm just going to take a guess, somewhere around 5 1/4, like 5.25. My Y value, again, anytime I have an X-intercept, my Y value is always 0. So there's your X-intercept. Now, these will not always be exact. Now, we can get exact versions, and this is a great time to talk about this. You can get the exact version of that X-intercept from your equation. You don't have to rely on the graph. Now, let's find us some lattice points. So my Y-intercept is actually a lattice point, and then I see another one right here. So this one's a whole lot nicer because each big box just counts 1. So my slope, again, notice it's downhill. I like to go ahead and put my negative sign. Then we're simply counting boxes. 1, 2, 3. Again, that's from one lattice point to the other. So my rise is 3. My run is 1, 2, 3, 4. So I have a slope of -3/4. Now, lastly, let's look at what we call a parabola, a quadratic equation. We'll talk about these a little bit more in depth later. But these are x-squared equations. X-squared equations also have y-intercepts where it crosses the y-axis. So that's going to be a y value of 8 and an x value of 0. Again, I like to say it over and over. Find a y-intercept, plug in 0 for x. Now this one's a little bit different because this one actually has 2 x-intercepts. My first x-intercept is 2, 0. My next x-intercept is 4, 0. And there's another part of this graph that I want us to go ahead and talk about. Just like angles have vertices, a parabola also has a vertex. In this case, the vertex of this parabola, and the vertex is the lowest or highest point on this parabola. So notice we go over 3 and down 1. So 3 comma negative 1 is our vertex. Sometimes we call this point V. Since it is the vertex, we can call it V the same way we could call these points P and Q or whatever we want to call them. But that would be the vertex of that parabola.